Finishing up this fundamental theorem of calculus, we now want to get started talking about the second fundamental theorem of calculus. This is something you absolutely must know for the AP test. And what it's basically telling you in the second fundamental theorem of calculus is that a derivative and an integral, when you take the derivative with respect to x and your bound is with respect to x, they actually cancel each other out, and it's like you're just plugging in your x value. So we're going to see how that works out on this problem. We're going to follow these directions so we can start to demonstrate what the second fundamental theorem of calculus actually looks like. So the first part, in part A, it says we are going to integrate to find f as a function of x. So that's all I'm going to do right now. I'm just going to integrate this. And in order to integrate this, it would be much easier if I thought of this as t cubed plus t. So now I'll be able to integrate this, and I can say, well, this is t to the fourth over 4 plus t to the second over 2, and I'm going to integrate this from 0 to x. So my f of x is equal to 1/4 x to the fourth plus 1/2 x to the second, and then it'd be minus 0, which I don't need to write in there. So that would be part A. In part B, it says demonstrate the second fundamental theorem of calculus by differentiating the part A. So I'm going to take, and in part B, I'm going to write what I just got for my answer. And remember what second fundamental theorem of calculus says is that if I differentiate both sides, that it actually cancels out that integral. And so I'll show you what that looks like below this, even though it's not asking me to do that in this problem. When I bring this out front, I'm going to differentiate it. I get x cubed plus I get x. Now that's exactly what I have right here. I actually have t cubed plus t, so you can see that they're exactly the same. So let me go ahead and do second fundamental theorem of calculus as like a little side problem. So if I'd actually used second fundamental theorem of calculus to find f prime of x, here's what it would look like. You would start out by this original problem, and it would say, you know, find f prime of x, which we're going to do on the next problems anyways, but this is just an additional one. So you would take the derivative of each side, and we'll go ahead and write that out. And what happens when you take the derivative is you get f prime of x is equal to these cancel, and all you're doing is you're substituting that x back in. And so we end up getting the same answer. So this is what the work we're going to be doing on the second fundamental theorem of calculus. I have two more examples like this, and I'll try to get through those in this video. So what I'm going to be doing is I'm going to be differentiating both sides with respect to x. So notice how I'm putting a d over dx on both sides. It does not matter what number that is. It can be 2, 5, it doesn't matter. It's a constant term. And what it's saying to do is to find f prime of x. Well, I'm doing that by taking the derivative of both sides. Whatever we do to one side of the equation, we have to do to the other. What that gives me is f prime of x is equal to, these cancel each other out as long as I put the x's in. I get x squared over x squared plus 1. The next one, we're doing the same thing. This one, it has one additional step, and these are the type they like to put on the AP exam. What you're going to be doing is you're going to take the derivative on both sides. So we know that these cancel, and we're going to just put that x value in. The difference in this one is that we also need to take the derivative of this, because it's not just a plain old x. We have to make sure and take the derivative of it. That's the one little trick to this. And then what you end up getting is you end up getting 2x over x to the 6th. And then what you can do is simplify that to be 2 over x to the 5th. So this is your derivative. These are the type, like I said, they like to put on the AP test. It'll be something where they have something other than just a plain x, so you use your second fundamental theorem of calculus, but then you remember to take its derivative.